Okay, today we're going to start chapter 2, and we're going to start off with section 2.1, lines and transversals. All right, so we'll look at parallel lines, perpendicular lines, and skew lines first, and then we'll start to talk about angles that are formed by parallel lines. So here we go, let's get a rocking and a rolling. All right, first word is parallel. All right, parallel are lines that run the same exact direction. All right, you'll notice our symbol for parallel is two lines straight up and down. All right, so for example, if I look at this picture, I notice line L and line M run the same way. All right, so we're going to write L is parallel, and you can put them straight up and down or on a little slant. L is parallel to M. All right, so parallel lines are lines that run the same direction. They can be diagonal, they can be up and down, all right, but they run exactly the same direction. All right, second term, perpendicular. All right, notice the perpendicular symbol is an upside down T. All right, perpendicular are lines that cross that form 90-degree angles. All right, so remember we look for that little symbol, little box, to show that it's 90-degree angles. So when I look at my picture, I notice line K and L form a box in the corner by the angle. So L is perpendicular to K. All right, so they cross to form 90-degree angles. All right, our last one is skew. Okay, now skew are lines that do not touch, they're not on the same plane, and they're not parallel. All right, so we sort of pick a line, and then we try to find a line that's not near it, not touching, not intersecting. All right, so for example, in this picture, you'll notice K runs horizontal over here. M runs vertical over here. They're not touching, they're not intersecting, they're not parallel. So M and K are skew. All right, so skew lines, they don't touch, they don't intersect, and they're not on the same plane, and they cannot be parallel. So now we're going to answer some of those. All right, in our picture, we're going to look for parallel lines first. Name a parallel lines. So we need to find two lines in this picture that run the same direction. Well, you'll notice H and G run the same way. So H is parallel to G. All right, now let's look at the next one. The next one asks us to find a pair of skew lines. All right, so I'm going to look for a line that's not parallel, not touching, and runs different directions. So you'll notice H runs horizontal, J runs vertical over here, so H and J are skew. All right, that brings us to our last one, perpendicular. All right, now perpendicular lines, remember, are lines that cross to form a 90-degree angle. So if I look, line G and line J meet to form a little 90-degree angle in the corner. So G is perpendicular to J. All right, so make sure you can identify those three terms. Now we can also start to look at a different picture and do this. If we look, name a segment parallel to DG. Well, when I look at this picture, there's two answers here that I could use. I only need to pick one. I notice that HE runs the same direction, so I could pick HE. Now notice it says segment, so we need to make sure we use segment notation above it. So HE could have been an answer. Some of you might have said, well, I saw FJ. That's fine. FJ is also correct. And again, you only have to come up technically with one answer, but we'll identify them all for right now. All right, let's keep moving. Name a segment perpendicular to GH. So let's find GH first. I'm going to highlight it. I need to find a line that's going to form a 90-degree angle or a box with that. So if you look, right here, if I go, I form my L or my 90 degrees. So it is perpendicular to HJ. All right, try highlighting the picture. That usually helps see it. All right, a segment skew to JF. So here's JF. Now remember, skew means I want a line that's not touching, not parallel, and not on the same plane. So like if I highlight DE, notice that runs a different direction and they don't touch. So I could use something like DE. I could use GH. That runs a different direction and doesn't touch it. All right. Those are the best two to use for skew because they're not touching, not intersecting, not parallel. Okay, name a pair of parallel planes. All right, so a plane, we want to use more than just a line here. If I name this plane and look at the front, I see DEF. So plane DEF is parallel. If I highlight the triangle in the back, these two run the same exact direction. So I could call it plane GHJ. All right, name one pair of perpendicular segments not including GH. Okay, well, we can't use GH for it, so I see another box here. Let me switch to a new color so we can see it. All right, I see a 90-degree angle form off of this right here, DE and EF. So, DE forms a 90-degree angle with EF. So they are perpendicular. Oops. Let's go back and rewrite that for you. That was DE and EF. All right, last one. Name one pair of skew segments not including JF. All right, so we can pick any line. So let's say I picked EF, and there's a lot of different answers you could use here. So EF, and I want to find a line that's not touching it, not parallel. So I could use GH. All right, again, your answers may vary. So if they ask you to pick one, you pick a line and then pick something away from it that's not touching and not parallel. All right, those are the big first three terms. Let's go through a little more practice with it and some more examples to make sure you're good. Name a plane parallel to ABC. Well, if I want to go parallel to that, I can go with plane TKG. Notice we did the same pattern that they did up above. Okay, parallel, same direction, runs the same exact direction. All right, next question. Name something. Name all segments that intersect AB. So here's AB. So we want to name any line that runs into that, any segment that runs into that. So notice TA, if I trace that, I hit A, so I intersect. I could say DA. If I trace that, you'll notice I intersect that original line. I could say CA. Notice if I trace that, I run into the line. Or I could say CB. Notice if I trace that, I hit the line. So intersect means we hit one of the 2 points of the original segment they gave us. All right, name all segments parallel to KG. So we want to find all lines that run that same direction. Well, I notice TH runs the same direction. I notice AD runs the same direction. And I notice BC runs the same direction. All right, so parallel, we all run the same direction. All right, name all segments skew to TK. So let's highlight TK and let's come up with things that are not parallel, not touching. Notice AD is not parallel, not touching. Notice AC is not parallel, not touching. Notice BC is not parallel, not touching. All right. The other ones are parallel. I could go with DH. That's not touching and not parallel. All right, the other ones are parallel or touching it. The last one you could use is CG. Anything else runs into either T or K or runs parallel with it, so we cannot use it. All right, again, we have to be able to name them all. No, you'll have to be able to name one for us. All right. Two segments that appear to be perpendicular, so let's look for an L. So there's a couple different answers. I notice right here looks like it would form the L, so I could say AT, is perpendicular to HT. I notice in the back that BK and KG look like they form it. So BK could be perpendicular to KG. All right, there's a couple examples of possible perpendicular segments. All right, let's keep moving. All right, here's going to be the big part of the section, big part of the chapter. These 4 terms are going to be huge. All right, so first one, corresponding. Corresponding are angles that lie on the same side of a transversal and on the same sides of the other 2 lines. All right, so what we have is we have parallel lines cut through by a transversal, and a transversal is a line that intersects 2 or more planes in different points. All right, it's going to form a bunch of angles. 8 angles are formed. All right, so notice angle 4 is below the line, and on the same side 8 is below the line. Those are corresponding. All right, there's going to be lots of corresponding. If I put a 1 here and a 3 here, they are corresponding. All right, so 1 on the same spot of the lines, same side of the transversal. If they're both above the line or below the line, it's corresponding. All right, alternate interior angles. Alternate interior angles are inside 2 parallel lines, and they alternate which side of the transversal they're on. All right, so 4 and 5 are alternate interior. They're inside 2 lines. They alternate which side of the transversal they lie on. All right, well, alternate exterior then. Interior was inside. Alternate exterior means outside. So we have 2 parallel lines. We have an angle on the outside and on the outside, and they alternate which side of the transversal they're on. All right, the last 2 we have is same side interior and same side exterior. We also call it consecutive interior angles. So again, this time we're inside, but this time we're on the same side. So same side interior or consecutive interior, they're on the same side of the line, same side of the transversal, inside 2 parallel lines. So for today, our goal is going to be to try to identify these. All right, we'll try to name them all, and we'll try to look at each picture and go through it and re-explain what each one means. So let's look at the following picture. All right, we've got our transversal, the line that splits them, and these are the 2 lines that we're going to look between them. All right, the transversal is the line that splits my 2 red lines. Now corresponding, we want them to be in the same spot, same side of the transversal, in the same location. So for example, corresponding angles could be 1 and 3. All right, 1's on the left side of this line. On the same side of my transversal, the 3 is on the left side of that line. We could go with 2 and 4. All right, 2 is on the right side of this line. 4 is on the right side of that line. They're both above the transversal. We could go with 5 and 7. 5 is on the left side of that line, 7's on the left side of that line, and they're both below the transversal. The last one we could use is 6 and 8. All right, 6 and 8 would work. They're on the right side of the lines, and they're both below the transversal, so they're in the same location. All right, let's go to alternate exterior. Exterior means this time they're outside the 2 red lines. They're not inside, they're outside it. They're going to alternate which side of the transversal they're on. So I see angle 1 is outside, and then if I alternate sides of my transversal and I stay outside, 8 is also outside. So 1 and 8 would go together because they're both outside exterior and they alternate sides of the transversal. The other ones that would work is 5 and 4. 5 is outside of the red line, 4 is outside of the red line, and they alternate which sides they are on the transversal. All right, let's look at same side interior. So this time the key word is interior, and we want same side of the transversal. So I need 2 that are inside the red lines. Well, angle 2 and angle 3 would go together. 2 and 3 are inside and they're on the same side of the transversal. 6 and 7 would go together because they're inside the two red lines and they're on the same side of the transversal. All right, the last one is alternate interior. Alternate interior means that we're inside interior, we're inside two lines, but this time we're going to alternate which side of the transversal. All right, so for example, let's start with angle 2. If I look inside and I alternate to the other side of the transversal, angle 7 is on the other side, inside the two lines. If I chose angle 6, I would pick angle 3 because 6 and 3 are inside, but they alternate sides of the transversal. So we're going to use the word to help us get through it. All right. Now, we can go ahead and classify each angles. Let's look at what they say. They say angle 1 and 2, so I'm going to highlight two lines. 1 and 2 are in between these two lines, so they're interior. Now I got to ask myself, are they same side of that transversal line N, or do they alternate sides? They alternate sides, so we're going to call it alternate interior. Alt-int is how we'll abbreviate alternate interior. All right, let's erase those green lines. And let's look at the next question. It says 2 and 4. All right, so I see 2 and 4. They're between these. Notice they are not both inside those two lines, so it is not interior. They are both not outside those two lines, so it is not anything with exterior. We have one above the line, one above this line, and they're on the same side of the transversal, so we call those corresponding, which we'll write C-O-R-R to abbreviate. Okay, let's look at our last one, 3 and 4. So here's 3 and 4. I notice 3 and 4 are in between two lines, so they're interior. All right, if they're interior, I have to ask myself, are they same side interior or do they alternate sides? In this case, they're on the same side. They're both above the transversal, so we're going to call it same side int, same side interior. All right, so locate lines first, see if you're inside or outside, and then proceed with caution from there. All right, you know they're going to make these pictures get crazy on us, so let's go ahead and look. They give us 6 and 10, so 6 and 10. So 6 and 10 are between these two lines. All right, I know they're interior because they're both lying inside. Now I'm going to ask myself, are the 6 and 10 on the same side inside, or do they alternate? In this case, they're same side. They both lie on the same side of the transversal, so same side int. All right, let's erase our red lines. Let's pick a new color, and let's move on to the next one. 9 and 11, so I'm going to locate 9 and 11. All right, I sort of see 9 here, 11 there, right? All right, let's look at it this way. If I highlight that, that didn't do me much, but if I look between 9 and 11 are technically between these two lines. So they're technically interior. Now I'm going to ask myself, are they same side or do they alt? In this case, they're alternate interior. All right, let's look for 1 and 5. Let's change colors to blue this time. All right, 1 and 5, I see 1 up here. I see 5 over here. Notice they are not both inside that line. All right, they're not both. I have 1 outside of it, 1 inside of it. If we have 1 outside of it and 1 inside, and they're on both the left side of the line, we call them corresponding angles. Okay, 3 and 8. I'm going to locate 3 and 8. I see 2 lines that go through them. Okay, I notice they are not inside my 2 purple lines. They're both outside, so it has to be exterior. Now I'm going to ask myself, are they same side of this line that splits it, or do they alternate sides? So it's either same side exterior or alternate exterior. Notice 3 and 8 alternate which side of that line they're on, so they're alternate exterior. All right, our last one is 7 and 12. So I see 7 and 12, and I see that 7, oops, let's do that line again. I see 7 and 12 are in between these two lines. Now I'm going to ask myself, if they're inside, they're interior, so they're either same side or alternate. They alternate which side, so it's alternate interior. All right, so you want to try to highlight the lines and then locate where they're at and go from there. Let's go ahead and look at the last picture, and then we're going to look at some. Now, are our pictures always going to be this complex? No. For the most part, our picture is going to look like this with a transversal splitting two parallels. All right, but for now, we're trying to identify them in these pictures. 7 and 12, so let's see. Here's a line. Here's a line. I'm going to ask myself, are 7 and 12 both inside those two lines? They are not. One is inside, one is outside. They're on the same side of the transversal, so we call that corresponding. All right, so again, we want to go through the process, ask ourselves, are they both inside, or are they both outside? If they're both inside, it's got to be one of the interiors. If they're both outside, it's got to be one of the exterior ones. If it's one of each, then it typically falls in the corresponding. All right, let's do 8 and 10. So I notice, here's a line, here's a line. 8 and 10 are both in between the two purple lines, so it's got to be something with interior. So my options are same side interior or alternate interior. I'm now going to check, are they on the same side of the line or do they alternate sides of the line? They alternate, so we're going to call it alt interior. All right, last two. 1 and 6. Oh, 1 and 6, a trick. 1 and 6 is from your old terms. Notice 1 and 6 lie next to each other on a straight line. From last chapter, anything that lies on a straight line right next to each other is technically called a linear pair. All right, so do not forget linear pair. That is going to be key. Vertical angles are also going to come up in this. So for example, if we said something like 1 and 11 or 9 and 6, those are vertical angles that are across from each other by the x that forms. All right, our last one, 2 and 12. If I trace this line here and this line here, and I compare 2 and 12, I notice that they're both outside of the line, so it has to be exterior. I'm going to ask myself, is it same side exterior, or did it alternate which side of this line that split it? All right, it alternates which side, so we call it alt exterior. So for the first section, we're going to just try to identify these, and eventually we're going to see which ones are equal and which ones add to 180, so we can eventually solve these. So today we want to try to be able to identify them. All right, good job with that. We'll practice it some more.